I'm Conor Hutton, and this is Lecture 3 in the Probability and Combinatorics section of Mathematics for Computer Science A. Here I'll just do a very quick example of combinatorial calculation for probability theory, an example from poker. Playing cards provide an easy set of examples for looking at combinatorics. I'm going to do a quick example here using poker hands. You'll all know cards, standard pack of playing cards. Well, it has cards with 4 different suits: diamonds, clubs, hearts and spades. And then for each suit you have 13 cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen, king. Now in poker, well, there's lots of different versions of poker. In stud poker you're dealt 5 cards, and so here's a 5-card hand: jack, queen, an ace, all in spades, another jack, this time in clubs, and a 2. So different combinations of the 5 cards have different values, and the players compete to bet on their hand being the best hand. Here, this hand is quite a poor hand. It's a pair of jacks. What we'd like to do is to calculate the probability that you get a pair of any pair. And so how do we do that? Well, it's one of the cases that we talked about just a second ago in the last lecture, to do with counting. So first of all, we want to know how many possible hands are there. Well, there are 52 cards, and in a poker hand, in a stud poker hand, you have 5, and so there is a different hand for each subset of size 5 out of the 52 cards. 52, of course, is equal to 13 by 4, 4 different suits, 13 different values. So 52, choose 5, well, it's going to be 52 by 51 by 50 by 49 by 48, divided by 1 by 2 by 3 by 4 by 5, and that's quite a big number. It's 2598960, so it's 2.5 million. Basically, there's 2.5 million different hands. So that's the sample space, of 5-card hands. What we'd like to know is the event of the hand containing a pair. Well, what we want is hands that are called a pair. In other words, there's 2 cards that are the same, and the other 3 cards are different. If there was 2 pairs or 3 of a kind, that's a different hand, a superior hand. So what we want to do is to work out the probability of getting a pair. So the probability of a pair by counting is the number of hands with pairs and just pairs over the total number of hands. A hand is any of these deals. So the total number of pairs is what we're after. So it's the number of pairs. And, well, how do we do that? We have to first of all choose the first card, the nominal value, or the card that's going to form the pair. So in the case of the hand I showed you, that was the jacks. And so there's a choice of 13 possible values for the pair. And so that's the start of it, 13. Now, when you have the pair, we've decided what value card the pair is going to be made of, but we also have to choose 2 cards to make up that pair, and that's a choice of 2 out of 4. So in the case of jacks, there's 4 possible jacks: hearts, diamonds, spades, clubs. So there's 4, and we're choosing 2 of them. So it's 4 choose 2. And now we have to deal with the rest. So we have to deal with the other 3 cards. We're looking for the total number of pairs. So we aren't just saying how many ways can you get a pair of cards, but we're saying how many hands have a pair in. And so that's, to do that counting, you need to know the pair, and you need to know the other 3 cards. And so there are 12 values left. So one of the values is already taken up. In the case of the example we saw, that was the jack, and so the remaining 3 cards must be chosen from the 12 values that haven't already been taken. Because if one of those cards was one of the remaining jacks, well, then that hand would be 3 of a kind. If 2 of those cards were jacks, then it would be a poker. Much better hands. And so we have 12 cards, 12 possible values, and we're choosing 3 of them, because we also want them to be different values. If the remaining 3 cards contain another pair, again, that would be 2 pair, a better hand. And now finally, we have 3 cards here. In each of these is a different value, and each of these must have a suit. Each of these must be one of the 4 possible suits, and so we have a 4 to the power of 3. So you can reason your way through it in terms of thinking about how you would construct the hand, how you would pick the cards for the hand. In this case, 13 choices of value, 4 choose 2 choices of suit. This is for the pair part. And then for the remaining cards, we have 12 choose 3 choices of value, 4 to the power of 3 choices of suit. So this is the remaining cards. And this, this is equal to 1098240. So it's just over a million. In other words, the probability of a pair is equal to this number here, as I said, just over a million, divided by the number we had before, total number of hands, which was just around 2.5 million, and if you work that out, it's 0.42. And so if you get a 5-card poker hand, there is a roughly 42% chance that it will contain, that it will be a pair.